One thing I noticed about Openstax Calculus Volume 1 and also the Leaving Certificate Project Math syllabus is that both require students to integrate things that would be described as a by parts integration problem. However, integration by parts is not in the Openstax Calculus book, nor is it in the Leaving Cert maths book. So there's this weird situation where students get these questions that require the biparts formula but can't use it because it was never taught to them. So instead, they have to use this kind of fake integration by parts technique. Let me explain this fake by parts technique. So consider an integration problem like this. We won't make it too difficult. We'll say x sine x. Something like this. Not too difficult. Now, this is a product. There are two functions being multiplied that need to be integrated. And the only way to really do that, not using the true by parts formula, but this fake one, is to make a substitution. And the substitution might seem a bit random. You say hx equals x cos x. Now, how did I, or why did I choose that, or how did I choose that? Well, you take the original and you integrate the second piece, the sine x, and that's it. You let hx equal to this function, x cos x. Well, I suppose really integration of sine x is minus cos x, so you could say minus cos x. Actually, you don't need to. It doesn't really matter if you have the plus or the minus here. The technique will work either way. But if you want to be strict about it, then I guess technically it's minus x cos x. Then what you do is you differentiate both sides. So on the left, we require the product rule. That becomes minus 1 cos x. And then the cos x becomes minus sine x. So we get that there. Then we integrate everything again. So that seems a bit weird. We differentiate and then we integrate. So we get back to hx, the integration of cos x, and then the integration of x sine x. Now, hx we know, it's minus x cos x. And the integration of cos x we know, it's sine x. And the integration of x sine x we don't know. But that's actually the question. If I was to take this over to the left, I would get sine x minus x cos x is equal to the integration of x sine x. So basically, I've turned my integration problem into a non-integration problem. In other words, I've solved it. The only thing that's missing is the constant. So integration of x sine x equals sine x minus x cos x plus c. Now, a couple of things. Number one, usually in the Leaving Cert exam, at least, this is written in the correct order. But if you've got a question like this, sine x times x, it would actually be easier to turn it into this form. It works better to integrate sine x and get x cos x rather than to integrate x and get sine x, x squared over 2. So how do we know if the problem is in the correct order? That is, how do we know if we need to swap it? Generally speaking, if we just remember this word here, make sure logs L is before inverse of sine cos tans. Sine inverse, cos inverse, tan inverse, also called arc sine, arc cos, arc tan, which is before algebra, like x, x squared, x cubed, root x, before trig, sine cos tan, before e, exponential, e power x, etc. So you can see in this question here, we have a and we have t. So this is in the correct order. No need to swap it, and we can go into integrating the second piece here. And this is the fake integration by parts. And if we want, we can check the answer. So if I differentiate this, I should get x sine x. Let's test it out. Sine x differentiates, becomes cos x, minus x cos x. We need the product rule here. So that would be minus cos x, minus x sine x, but it's actually minus sine x, so that becomes a plus, and the c is gone. These cancel, and we're left with x sine x. So it checks out. It checks out. We have successfully integrated here, and that is the answer, using the technique which I am calling fake integration by parts.